Hello, in this video we're going to take a look at finding the relative or local extrema of a graph and of a polynomial function. So first let's look at the graph. So extrema can be either a maximum or a minimum, and the local or the relative max or min just means that if we zoom in just on that part of the graph, it's going to be the highest point. It doesn't necessarily have to be the highest point of the entire graph. So this first one we see has a maximum here at the point -3, -2, and we have a minimum at the point -1, -5, because if we zoom in on just those little areas, that is the highest or the lowest point. So looking at a graph, it's pretty easy. This is going to have a relative or a local max of -2 at -3. So a maximum, when you see the word of, that is telling you the y value. And then when you see the word at, that is telling you the x value at that point. So it's got a maximum of -2 at x = -3, and it has a local or a relative min of -5 at x = -1. All right, so what if we don't have the graph, but we have a function, the equation here? So let's look at how we would do the same type of problem, finding the local or the relative extrema from an equation. Here we have a basic polynomial equation. I've got some other videos that go through examples of different types of functions, but this one's kind of the basic starting point. So the first thing we need to do is find the critical values, and to do that we need to find the first derivative. So our first derivative of x to the fourth minus 128x squared minus 4 is 4x cubed minus 256x, and then the derivative of -4 is 0. All right, so this function, we weren't given any kind of real-world limitations on it, and the domain of a polynomial is all real numbers. So that means anything that makes this derivative equal to 0 or undefined will be a critical value and could potentially be a relative max or min. So we need to find those critical values. Polynomials are never undefined, so we don't get any critical values from that. So we need to figure out when this function is equal to 0. And I see that we've got a greatest common factor there of 4 and x, so I'm going to go ahead and factor that out. That's going to leave us with x squared in the first term and -64 in the second term. X squared minus 64, that's a difference of squares. Excuse me. And so we can factor that, x squared minus 64, x minus 8 times x plus 8. And so here we have 3 x's in our completely factored form. So that means we're going to get 3 critical values. 4x is equal to 0 when x is equal to 0. X minus 8 is equal to 0. We can add 8 to both sides and we get x is equal to 8. And x plus 8 is equal to 0. When we subtract 8 from both sides, we get -8. All right, so those are going to be the values. What I'm doing here is what's called the first derivative test. There is a second derivative test, but we'll talk about that later on. And so I'm going to put those, I'm not going to really worry about getting this to scale, but I do want to make sure that I have the numbers on my number line in order, the smallest or most negative on the left, the biggest, most positive on the right. And then now we're going to pick a value in between each of those. So I'm going to pick -9, -1, 1, and +9, and I'm going to plug that into my first derivative. So f prime of -9, I don't necessarily need to know the number here, I just need to know whether it's positive or negative. And I see if I plug in a negative number, that I'm going to get a negative for my first term, and if I plug in a negative, I'm going to get a positive for my second term. So this one, what ends up happening is that 9 cubed is going to be much bigger than the rest of it. So what we end up getting is a negative number when we plug in a -9. And so that means our function is decreasing. If we plug in -1 into that same function, now the 256 is going to be the dominating part, and it's going to end up making that overall derivative positive. And so anytime the derivative is negative, that means our function is decreasing. Anytime the derivative is positive, our function is increasing. And I like to draw my arrows kind of tilted over to the right as opposed to straight up and down, so that it makes it really clear what's happening on the graph. It's going down, and then here at -8, it's going to hit a bottom and then turn and go back up. All right, if we plug in +1 now everything's positive. That 256 definitely is going to dominate, and this time we're plugging in a +1, so that's going to make that a negative number, meaning it's decreasing on that interval. And then if we plug in a +9, now the top's going to be dominating, and that's going to make it, or the 4x cubed, the first term, is going to be dominating. And so it's going to go back to increasing. And so we can see that our graph is going to go down and then back up and then down and back up, kind of like a roller coaster. So those points are going to give us relative maxes and mins at all of them. Now that's just telling us where those max and mins occur, at 0, -8, and +8. Now we need to figure out what those max and min values are, and to do that we're going to plug into our original function. So now we want to take each of those critical values and plug back in. Now we're plugging into this original piece right here, and now we do need to know what that actual value is. If we plug in 0 here, we can see that we get a -4, and if we plug in 8, let's see, plugging in 8 gives us a -4,100, and plugging in a -8 also gives us a -4,100. Now, it doesn't necessarily mean what the numbers are here, which one's bigger or smaller. It has to do with whether it's increasing or decreasing on each side. And so we do see that both of those relative mins, this one is going to end up being a symmetric function, even, odd, and neither. You might want to check that out. This is going to be a completely symmetric across the y-axis here, and that point on the y-axis is going to be our relative maximum. So we get a relative max of -4 at 0. Remember, of means y, at means x. And we get relative min values. Both of them are going to be -4,100 at both positive and -8. All right, I'll see you guys next time.